Introduction of Law of Mass Action. This law is given by C.M. Goldberg and P. Wirch in 1864. Statement of Law of Mass Action. The rate at which substance reacts is directly proportional to its active mass, and the rate at which reaction proceeds is directly proportional to the product of active masses of the reactants. This law contains two parts. In the first part, it talks about substances. In second part, it depends upon rate of chemical reaction. The first part says that substance react speed is directly proportional to the active masses. Active mass means the mass of substances or reactants that takes part in chemical reaction. And the speed of chemical reaction depends upon the product of active masses of reactants. Important term, active mass. What is the meaning of active mass? It is the molar concentration of reactants and products in mole per cubic decimeter, and it is represented by square brackets. From the daily life example, you can understand the active mass. For example, you buy 5 kg of chicken, and from that 5 kg of chicken you are going to cook 2 kg of chicken. That 2 kg of chicken is your active mass, and the rest of 3 kg chicken that is stored in the freezer, it is not the active mass. So it means active mass means the substance or the reactants that are participating in chemical reaction. Okay, now we are considering an hypothetical equation A plus B. It is equal to C and D. These two-sided arrows indicating that this is reversible reaction. Now you know that what is reversible reaction? Reactants are forming products and products are reforming reactants. Okay. Small a, small b, small c and small d are representing coefficient numbers from the balanced chemical equations, or you can understand that they are number of moles that we use to balance a chemical equation. Okay, now chemical equilibrium or equilibrium constant, it is indicating by K. K is equals to product upon reactants. And again, these are the square brackets. They are indicating concentration at equilibrium. Okay, according to the law, what law says? Rate of forward reaction. Rate of forward reaction directly proportional to the reactants A and B. And this proportionality sign is changed by Kf. K is proportionality constant and F is indicating forward reaction. And square brackets, again the active mass A, and these small a and small b are the coefficient numbers are becoming powers or the number of moles. This is equation 1. Rate of forward reaction. Okay, now same as it is, we have equation number 2. Rate of reverse reaction directly proportional to the products, and we have products C and D. And again, these small C or D are coefficient numbers or the number of moles that becomes power. Now we have two equations, equation number 1 and equation number 2. Okay, Now at equilibrium state. Equilibrium. Equilibrium means rate of forward reaction is equal to rate of reverse reaction. So we are putting the values of forward reaction, equation number 1, will become equal to rate of reverse reaction, equation number 2. Look at here. Kf, forward reaction, is equal to reverse reaction, and by cross multiplying, here this Kr is multiplying, and when we are moving it here, it will be divided. So Kf upon Kr, this A and B is multiplying over here. By cross multiply over here, it will be divided over here. So we are going to get Kf upon Kr is equal to Kc, and it is product upon reactant. And this Kc is equilibrium constant or equilibrium constant expression. Okay, now the definition of equilibrium constant expression or Kc. Equilibrium constant or the Kc is defined as the ratio of product of concentration of products to the product of concentration of reactants, each raised to the power equal to the coefficient or the number of moles in a balanced chemical equation. We calculated Kc is equal to product upon reactants, and it has powers, and that powers are coming from coefficient numbers or the other number of moles that we are used to balance chemical equation. Kc or the equilibrium constant expression depends upon temperature, but it is independent of initial concentration of reactants or products. Okay, now you see I am giving you examples how to write equilibrium constant expressions. Look at the equation. Nitrogen plus hydrogen is given ammonia. There are two arrows, forward arrow and reverse arrow. Forward arrow means reactants forming products and the products forming reactants, reverse reaction. So Kc or the K equation is equal to product. This is product and this is reactant. And this 3 is number of moles, that becomes power, same as it is here. Okay, now in equation number 2, this product ammonia is taken as reactant and it is given as nitrogen and 3 moles of hydrogen. How to write Kc expression? Product, now we have product as nitrogen. These square brackets are indicating the active masses, and hydrogen, and this 3 is indicating the number of moles or coefficient number, that becomes power, and we have ammonia. As it is in next equation, reactants forming the products, and we are writing Kc expression as product upon reactant. Okay, now I'm giving you a recap. What is Kc? Kc is product upon reactant. Any product, any reactant from any hypothetical equation, from any general, from any real equation, upper side, the denominator side is always product, and the denominator side will always from reactant hand side. Okay, look at here. The coefficient numbers, the small alphabets are increasing number of moles, and inside the arrow, inside the square brackets, we have concentration of products. Same on the denominator side, concentration of reactant A inside the bracket, and number of moles of reactant B, small alphabet. Okay, now you can tell me concentration of which species are taken in the denominator and the Kc expression. Can you answer me? Yes, in the denominator side we have always product, and where the coefficient number in a balanced chemical equation, it becomes power. Now your homework or the assignment, questions are given. Question number 1, who proposed the law of mass action? Question number 2, state law of mass action. Okay, now equations are given to you. Now you have to write Kc expressions. Thank you.